Hello everyone, welcome to my channel Aptitude Club and hope all of you are doing well. Today in this video we are going to do this beautiful question on alligation. Now we can do this using the method of average, but I'll try and use alligation, and we'll try and see how this question can be solved very easily, super easily, if you can apply the concept of alligation to this. As usual, I'll ask all of you to pause at this moment and try this question yourself first and then look at the explanation. Alright. So let's get into solving this. The bowling average of a cricketer. This was a previous year question only. The bowling average of a cricketer was 12.4. So let's understand what is bowling average. Now those of you who are familiar with cricket will understand this easily. Those of you who are not, what do you mean by bowling average? There are two types of average in terms of cricket: bowling average, and we can have a batting average also. So these are two like different terms. And how to define batting average? This is simple. Batting average is basically the number of runs scored by a batsman divided by the number of matches. Because the purpose of a batsman is to score runs. So per match, how many runs is he scoring? So accordingly, what's the purpose of a bowler? The purpose of a bowler is to take wickets. So bowling average is calculated like this: number of wickets taken sorry, not number of wickets taken, number of runs conceded per wicket. It is not number of wickets taken per match. It is number of runs conceded divided by number of wickets taken. That means to take a wicket, how many runs does the bowler concede? That is the meaning of like bowling average. That means here, if it is saying the bowling average of the cricketer was 12.4, that means for every 12.4 runs that the bowler concedes, he takes a wicket. That is the meaning of bowling average. Now, when I say the bowling average is improving, that means you concede lesser runs per wicket. So improving the bowling average means the bowling average comes down. Improving the batting average means the batting average goes up, because you would want the batsman to score more runs per match, but you will not want the bowler to concede more runs per wicket. You will want the bowler to take as many wickets as possible with lesser number of runs conceded. So if my bowler concedes 20 runs and takes 3 wickets, so bowling average will be 6.66. So I'll want that if the bowling average has to go up, so you conceding lesser runs, the bowler has to concede more wickets. That is the tricky part of this question. So when the bowling average has improved from 12.4 by 0.2 points, that means the new bowling average from 12.4, it will be minus 0.2. So it is 12.2 and not 12.4 plus 0.2. That is the trick of this question, that bowling average, when it is improving, that means it is reducing. It is not increasing. So improvement doesn't necessarily mean an increase every time. Had it been the batting average, so if the batting average would have improved, that means it would have gone up, increased. But when the bowling average is improving, it will decrease. Okay, because more wickets are taken for lesser runs considered. So bowling average improvement means you take more wickets. So if the denominator goes up, the bowling average comes down. So 12.4 improved by 0.2 points in terms of bowling average. The new bowling average is 12.2. This is what the question is. And why did the bowling average improve? Because in the last match, the bowler took 5 wickets for 26 runs in the last match. So let us put it into data form here. So let us say there were n matches played before. So here the bowling average was 12.4, and let us say x wickets taken. Then we had a last match where 5 wickets were taken in the last match and 26 runs conceded. This implies last match the bowling average was 26 runs by 5. It was 5.2. So amazing performance. Usual performance was 12.4, but in the last match took 5 wickets just conceding 26 runs. So the bowling average is 5.2. As a result, in total n plus 1 matches now. In total n plus 1 matches, the bowling average, overall bowling average, it improved by 0.2 points. So 12.4 minus 0.2, the bowling average has become 12.2. This is what has happened. Some matches were played before, and let us say in those matches X wickets were taken. We don't know how many wickets and how many matches were played. So these two things are not known. But in the last match, 5 wickets were taken, conceding 26 runs. So the bowling average is 5.2. So when I take the overall scenario, 12.4 and then 5.2, so I'll get somewhere in the middle. So I got 12.2. So if I put it into alligation, solving wise, in my experience, is not difficult. What is difficult in alligation is to comprehend the question and put the values correctly. So typically we have 5 parts. So 12.2 is my overall average. The usual average was 12.4 and in the last match it was 5.2. So when I take this difference, 5.2 and 12.2, this is 7 and this is 0.2. So in alligation this gets interchanged. So I get 0.2 is to 7 or 2 is to 70 or 1 is to 35. So we got a ratio. Now the bigger question is, this is ratio of what? Ratio of what? This is where the understanding of alligation comes into. What is it that I have taken on the top side? So alligation, there's a top level and there's a bottom level. So we'll call it as average 1, this is average 2, this is overall average, this is weight 1 and weight 2. Whenever we get a weighted average situation, we use alligation. So what I have taken in the top is average, which is the bowling average. Bowling average is runs conceded, let me write here again, divided by number of wickets taken. So whatever you have taken in the denominator, okay, you will get the ratio of that in the bottom level. So W1 is to W2 will be basically the ratio of wickets taken. Because I got the ratio, how will I know this? Is this the ratio of the number of runs considered or the number of matches or the number of wickets taken? How do I know that? So for that you have to understand what is it that you have taken on the top. You have taken bowling average. So whatever is there in the denominator of that will be in the bottom level. So W1 is to W2 will be the ratio of the wickets taken. That means 1 is to 35 is the ratio of wickets taken. Now 1 corresponds to 5 in our case, because in the last match where the bowling average was 5.2, number of wickets taken was 5, and 35 will correspond to X, number of wickets taken before the last match. So if 1 corresponds to 5, X will correspond to 35, which is 35 into 5, that is 175. That means number of wickets considered before the last match or number of wickets taken before the last match was 175. 1 is to 35 ratio. This 1 actually corresponds to 5 because in the last match the bowler took 5 wickets. So if 1 corresponds to 5, 35 will correspond to 175, which is nothing but X that we had taken here. How many wickets did he take in the taken before the last match? In the last match it was 5 wickets taken. So this to this we got it as 1 is to 35 and then 35. So total number of wickets we got here as 175. The solving part was easy, but we'll have to understand the question, what it was saying, and then accordingly solve. Beautiful question. And if you can understand how can alligation be applied, you can solve it super easy. Not a lot of solving. I wrote it so that you can understand it in a very systematic manner, but actual solving is this: just put the values, interchange. 1 is to 35, so 5 and 175, done. 30 seconds, max 1 minute, if you can understand what bowling average is. And this is a very important concept, that if I have taken on top level bowling average, whatever comes in the denominator. So suppose I am taking profit percentage, so in the denominator I'll get the ratio of cost prices, because profit percentage is profit divided by cost price. Suppose I'm taking rate of interest in the top level, then the ratio of principal is what you get as W1 is to W2. So alligation can be used in a lot of context. If I'm taking concentration, the bottom thing will be quantity, ratio of quantity taken. So accordingly, you can like think what will be in the ratio part, because I've seen a lot of times students asking, how do I know what is this ratio? किसका ratio आ रहा है नीचे कैसे पता चलेगा? So you refer to the denominator part. Whatever comes in the denominator, you will get that ratio in the bottom. Okay. So that was it from my end for this question. Hope all of you like understood the explanation of this and understood how alligation is applied. Try and solve more and more questions on alligation. Do check out the previous videos that I've done on this channel. I'll pin it in the I section. If you have watched it this far, do subscribe to my Aptitude Club channel and explore the previous videos, be it on quants or LRDI. You'll definitely find them useful on your CAT preparation journey. We'll meet again very soon on yet another video. Till then, keep solving and keep studying. Have a nice day. Bye bye.